We'll discuss very important concept of transformation of absolute functions in this video. Factoring of trinomials is one of the most important topic. We have 10 examples here to factor ax squared plus bx plus c. The playlist, however, has more than 100 examples to explore. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will learn how to factor trinomials of the form y equals to ax squared plus bx plus c, where a is not equal to 1. So we'll factor y equals to ax squared plus bx plus c. We have 10 examples for you. As you can see from here, question number 1 to 5 are relatively simple. And then we have question number 6 to 10. These are slightly more complex. We're working with higher numbers. But I hope that with these 10 examples, you will master the strategy to factor trinomials, any trinomial for that matter. Perfect. In case you want to learn from me, you can always send an email on the address given. Most of my students are getting excellent marks. Some of them are right there on the top, getting awards and scholarships like Akshit.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Now, let us begin with the solution of these 10 questions, basically factoring trinomials. We'll begin with the very first one. Try to understand the concepts as we move along so that by the end of this video, you have mastered the strategy to factor trinomials. The very first trinomial given to us is 2x squared plus 7x plus 6. The idea is to find two numbers whose product, let's say the two numbers are p and q, whose product is product of a and c, right? That is the product. Let me write a general rule here. We're looking for two numbers p and q whose product will be a times c and whose sum will be coefficient of x, which is b, right? So a times c, we're looking for a product and sum as the coefficient b. Perfect. So that is a common strategy. The idea is how do we apply it effectively. 6 times 2, as you know, is 12. You can get 12 in many different ways. However, 4 times 3 is something which when you add gives you 7. So this is good parameter for us since 7 is sum of p and q. Correct? So looking into this, the next step becomes that we need to split the number in between 7x this time as a combination of 4 and 3, both positive. So what we get here is 2x squared plus 4x plus 3x plus 6. The order of 4x and 3x really doesn't matter. Now you factor with groups. So you can form groups of 2 and then factor each group. So when you do that, you can factor 2x from the first two. You get x plus 2. And from the second group, plus, because that is the sign there, 3 is common, you'll get x plus 2. Always, always, when you do this step, you should get the same factor as we got here, both x plus 2. Otherwise, you've done a mistake somewhere. You get the idea, right? And now we can factor x plus 2 since it is common to both. And what we get is the factored form of this particular trinomial. You get the idea. So we can write this trinomial as equal to x plus 2 times 2x plus 3. Now some of you can verify the result. Let's move forward with doing the others. I hope these steps are absolutely clear. So basically, you're looking for a product of A and C, which in this case is 2 and 6, and sum of B, which is coefficient of x, 7 in this case. Split it into 2. Then take two terms and factor them individually. You'll get a common factor in both, which will help you to find the final answer. Here is question number 2. I think you can now pause the video. Answer. We have 6x squared minus 23x plus 15. So what is the product which you're looking for? 6 times 15, right? So we're looking for a product of two numbers, which is positive 6 times 15, right? That is 90. Now, you can get 90 in many different ways. How do we get minus 23? Now, to get minus 23 and product as positive, see, we want the sum as equal to minus 23. Negative sum means one of the numbers, both the numbers should be negative, because if you multiply two negative numbers, only then you get a positive number. So 90, how do you get 90? Now, that is sometimes very challenging. So what you could do is, you could split this into smaller factors. For example, 6 is 2 times 3 and 15 is 5 times 3. And then you can look for combinations here, which could give you sum of 23. Both have to be negative, right? Only then you get sum of 23. You get the idea. So if you do, let's say 15 and 6. So what is 15 plus 6? That doesn't make it, right? So 23, how will you get? Both negative. So if you use, let us say 20, let's say 5 times 3 is 15, and that doesn't work. So 5 times 2 is 10, and 9, that doesn't work. So now you need to figure this out. So can you help me find this combination? Well, 9 times 2 is 18 and 5 can give you the combination, correct? It's slightly difficult. If you multiply these three numbers, you get 18 and then you have 5 there, correct? So we have two numbers here, which is both should be negative, and that will work for us, right? So we can now split 23 as 6x squared minus 18x minus 5x. Makes sense? Plus 15. So there could be challenges in doing this process. However, if you break them up into smaller factors, it can become manageable, right? This was not all that complex. So get ready for the next 5 set of questions. So this gives me x minus 3 as a common factor, and here minus 5 is common, and we get x minus 3. Since x minus 3 is common, we have 6x minus 5 as our answer. So clearly, I could now write down factored form of this particular trinomial as x minus 3 times 6x minus 5. Is that clear to you? Now in this particular part, we have learned, if the numbers are difficult to work with, you can break them into prime factors and then find the solution. Let's do the next one. I'd like you to pause the video and answer this one. The question here is given to us as 8x squared plus 2x minus 15. So what is the sum and product? Let's write down the product first, right? See, we always write product first since there are lesser combinations, right? There is no need to multiply 15 and 8, right? It is a big number sometimes. Just leave it as such. Important thing is we want the sum p plus q as 2, and that too positive, right? And product is negative. That means the two numbers are very close. Bigger number is positive. So something which is like a square root could be good for us, right? So 16 square root is 4, and this is kind of between 2 and 3. So maybe 12 could be a good combination. So what we do here is we again look into the combinations of prime factors, which is 5 times 3 here, and 8 is 2 times 2, right? So we have split them into prime factors, correct? Now we're looking for 2, whose difference is just 2, right? So if I have 5 times 4, we get 20, and 3 times 4 is 12. So 10 and 12 can work, right? So we estimated the right number. So we have here combination of 10 and 12, bigger number being positive. So we could write this as 8x squared plus 12x minus 10x minus 15. Now it is important to write equal to sign. Sometimes I miss it. However, in the test, make it a practice to put the equal to sign. Make sense, right? Now what will you do? Between 8 and 12, 4 is a common factor. So we get 4x as common, and we get 2x plus 3 as common between the first two terms. Minus 5 is common in the other two terms. That leaves us with, again, 2x plus 3. Right? Always, the others will be common, right? Otherwise, you cannot move forward. Makes sense. Okay. So when you take 2x plus 3 common, you're left with 4x minus 5. So we got the factored form. Does make sense to you, right? So we have 2x plus 3 times 4x minus 5. Clear? Let's move on to the next question. However, I hope you appreciate by now that this factoring to prime factors is key. Question number 4. You can now pause the video. Answer this one. It's a relatively simple question. I have purposely put it here so that you could easily do it. Gain some confidence, right? So we're given the question here is 2x squared minus 32x plus 30. So what is the product and sum you're looking for? The product we are looking for is 30 times 2, right? You see, I don't really multiply them. And the sum, which is p plus q, is minus 32. So both numbers should be negative, right? Okay. So what should we get? Minus 32. Since 32 is a very big number to get in the center, two different numbers. So we are looking for extreme kind of things, right? So what numbers can work? 32 we need, right? So definitely the bigger number is negative. So let's split this 30 into its prime factors, which is 5 times 2 is 10 times 3, right? And 2 is 2 alone. Now from here, you can see if I multiply, because I need a big number, right? Since I need a big number, I can actually take two negatives, which are 30 and 2, right? So 5 times 6 makes it 30, and that combination can work, right? So we are going to write this as 2x squared minus 32 can be written as a combination of minus 30x and 2x plus 30, correct? So first two terms get 2x common and we get x minus 15 here. And here also we have 2 common and therefore we have x minus 15. So now x minus 15 is common factor. We get 2x minus 2. You notice that 2x minus 2 means 2 is also common, right? So sometimes what you could do is you could group factor. Now this time you cannot leave it here. 2 is common here, so I'm taking 2 as a common factor and then writing this as x minus 15 times. Dividing this by 2 gives me x minus 1. You get the idea. So in such cases, it's always a good idea when you observe that you have something where a group factoring can be done. You could do that, right? So we could factor out 2 first, right? So then it becomes x squared minus 16x plus 15, correct? Now that is very simple to factor. Product of 15 and minus 16 is 15 times 1, both negative, right? So you get 2 times x minus 15 times x minus 1. So now you learn that doing a group factoring right in the beginning many times always will help. So you should look for a group factor first and then continue with the steps which you have learned in these examples so far. So another strategy which you can note now is do the group factoring if possible and then continue with product and sum. So that brings us to the 5th question of the first set. I'd like you to now pause the video and answer this. We have 9x squared minus 9x plus 2. Product of two numbers which we are looking for is 9 times 2. And the sum of these two numbers should be minus 9. So what could be these numbers, right? So to figure this out, 9 times 2 is 18. 6 and 3 can work, right? Both negative. So 6 and 3 can work, right? Both negative. So sometimes it's simple, so you can do direct. So minus 6x minus 3x plus 2. And then 3x is common in first two, giving us 3x minus 2. And minus is common in the other two, giving the same factor, 3x minus 2. If somehow you don't get this 3x minus 2, that means you've done a mistake. Get the idea. And nothing here means 1. So we factored this one also, getting that to 3x minus 2 times 3x minus 1. Makes sense? So with this, we have done the first 5. I hope you understood the method. We'll do the other 5 also. Now, in case you really want to learn from me, you can always send an email on the address given. Here are the other 5 questions for you. Now, these are slightly more difficult. As you can see, we are leading with bigger numbers. So let's see, how do we do question number 6? Now, question number 6 is slightly different from others. So I thought I'll add some variation, right? So it is 25x squared minus 78xy plus 49y squared. I hope you remember the formula for a plus b whole square. Some of the times you may get a perfect square, right? Both factors being the same. So let's write down the formula. What is a plus b whole square equals to? It is equal to a square plus 2ab plus b square. And in case we have a negative sign here, then we have minus 2ab. So that is perfect squares, as you can see, and that is also factoring, correct? So in this question, you observe that 25x squared. 25 is a perfect square. We could write this as 5x whole square. 49 is 7 squared. So we could write this as 7y whole square. And the center term, fortunately for us, is product of 2 times the number 7 times 5x times y. So I wrote the numbers first, right? 2 times 5 is 10 times 70, which is 2ab. You get the idea. So if you compare this with the formula itself with a negative sign, you do realize that this is a perfect square. And therefore, I could rewrite this as equal to 5x minus 7y whole square. Do you understand it? So that is the way. If you identify this as a perfect square, you could do it in 3 steps. Otherwise, you can try with product and sum, just as you did the others, right? Okay, let's move on to question number 7. So this is relatively simple. In this set, we are given 6x squared minus 23xy plus 15y squared, right? Now this one we did earlier, so I'd like you to do it on your own. Perfect. Minor variation is that we are also having the term y's here. Okay. Question number 8. So question number 8 is 12x squared plus 20xy minus 8y squared. So you notice that 2, rather 4 is common, right? So this time we are not going to make a mistake. We take 4 as a common factor, right? So we get 3x squared plus 5xy minus 2y squared. You get the idea. And now we can do product and sum. We're looking for the product of two numbers, p and q, to be equal to what? Well, it should be equal to 3 and minus 2, right? Which is minus 6. And the sum should be equal to 5. Not just 5, because coefficient of x is 5y. And this is actually product of minus 6y squared. You get the idea. We're looking for the coefficients, right? So the coefficient and this constant is actually minus 2y squared. So make a note of this. And therefore, the product and sum is what we have written here. Make sense? So the two numbers whose product is minus 6 and sum is plus 5 will be what? 6 times 1, right? So bigger number is positive. So we have 6y and we have minus y, correct? So split this into these two numbers, writing this as 3x squared plus 6xy minus xy, right? So we got 5xy, right? Minus 2y squared. It doesn't make sense. Now, you can take, so it's good to put square brackets here. And the first two, you can take 3x common. So we have 3x common, and you get x plus 2y. And in this case, we have minus common, and we have y also common. And therefore, we have x plus 2y. Is that clear to you? And that gives you the solution. Perfect. Can you write down the solution here? 4 is already there. Don't ignore that. You get x plus 2y as a common factor multiplied by 3x minus y. Make sense? So that becomes your answer for this particular question. Correct? Here is your 9th question, which is relatively simple. You can now find the solution for this one, right? So I'm skipping. Some of you will note interesting technique, right? Question number 10 is equal to 12x squared plus 13xy plus 3y squared. So we're looking for the product of 3 times 12, which is 36, right? So we want to multiply two numbers and we want to get plus 36. And what is the sum? Well, the sum of these two numbers should be equal to 13. So what could be these numbers? 9 and 4 can work for us, correct? Perfect. So we could write this as 12x squared plus 9xy plus 4xy. That gives you 13, right? xy plus 3y squared. And taking 3x common here, we get 4x plus 3y. And here we have y common. So we get 4x plus 3y. And finally, taking 4x plus 3y common, we get our answer 3x plus y. You get the idea. So that is how you actually factor. So I hope with 10 examples, all very different and with higher difficulty level as we moved along, and of course some practice questions which were not that difficult. If you have practiced in between with me, I'm sure by the time we finish this exercise, you are already a master on this particular topic. In case you have any doubts or you want to learn any topic on mathematics, feel free to contact me on the address given. You can also contact our website for new updates. Thanks for your valuable time and suggestions. All the best.